All right, welcome to Computer Science 305. This is the second part of the first Java lecture. And in this one, we're going to be talking about simple expressions and statements. And so in Java, we have the capability for what we call primitive types, right? There's only a few of them versus, for example, if we look at C, C++, which has an extreme amount of primitive types. In Java, we have, and these are not all of them, but it's very close. There's int, which is basically a value between negative 2 to the 31st power to 2 to the 31st power minus 1. Character, which is a, instead of being, so essentially we can think about this as an int is a 32-bit numerical value. Character is really it's a character, right, as in a single part of a string, but it's also a number that is between the, which is a 16-bit integer. All right, and it's there to represent the Unicode character set. Then we finally have double, which is an IEEE 64-bit standard double value. I would suggest you look that up because when it comes to comparing equality of doubles, you can't do that. And you need to learn how to actually do that correctly. Although in Java, there's a slicker way of doing it now as part of Java 7. Then we have Boolean. Boolean gives us true and false. Now, we note that missing things here are long. Long is a 64-bit integer value, and float, which is a 32-bit IEEE standard floating point decimal value. All right. Boolean, which is the true-false value, and then we have these other two kinds that are their own types, which are void, which tells us that a method returns nothing, and then we have null, which is the null object. It's an object type, but means the object refers to nothing. Ah, yes, and the ones that we won't use. Oh, yes, I forgot short. Short is also a 16-bit integer value, and byte is an 8-bit integer value. We won't be talking about these as part of this lecture, but they are available. Longs can be referred with an L at the end of the number if you to ensure that the primitive, like the actual literal value, isn't. So if I put 0, right? 0 can be a double, int, long, short, byte, char, and depending on what I put after it, will indicate which one it is, right? If it's a 0 by itself, it's assumed to be an integer unless I put an L following it, which makes it long, or an F following it, which makes it a float, or a D following it, which makes it a double. So lots of good stuff there. So then we also, those are primitive types, right? We know that there's an enumeration and we know exactly what they are. And so anything else in Java is an object, right? Or a constructed type. That includes string. It includes pretty much anything else that you've ever seen in Java. So constructor types are all reference types or object types, right? References two objects in memory. So any class name like point, any interface name, which we'll talk about in Java Part 2, and then any array type, right? You can have an array of primitives, as it shows here, like the int followed by the square brackets is actually an object of type array, or a reference type of type array. So then we have strings, right? Strings are predefined but not primitive type, right? They're the only class type, well, except for arrays, that has like an actual literal value, a way to define it in a that's different than your typical objects in Java, which we use the new keyword or something similar to that. So a string, as we expect, is a string of characters enclosed in double quotes. We all should know that. Works just like a string constant. But we have to know that the string literal is literally a instance of the string class, therefore has methods that we can call on it, and works just like any other object. So, for example, if we have the hello there, in reality what it is this object that we show here, right? It's got its data is hello there, its length is 11. That's in code points, not in characters. Don't be confused. And then there's lots of things we can do with this, right? We can actually look at the length. We can find what is the ith character. We can make it uppercase, lowercase. We can split it. We can do all the different things as defined by the current version of Java's actual API definition, right? So you go look it up in the API docs, and you'll actually find out all the different methods that apply to string. Also note that string itself is a what's called an immutable type. So if you make any what would be a changing, like for example, if I concatenate a string together with another one, it doesn't change the original string, it creates a new string. So just bear that in mind. So then in Java we also have a variety of different operators that we can apply. For example, we have the typical plus, minus, star, divide, modulo, and the unary negation operators that apply to numerical values, including int, double, float, char, etc. And they will do different things. So if we have two ints and we do a division, right, it's going to do what we'll call integer division, right? There's no floating point. It rounds down to the next whole integer. And then what we can do is if we use the modulo operator, that's going to give us the remainder value from that same division if we use the same operands. On the other hand, if we do multiplication, right, multiplication will return, if we use multiplication division on a double or floating point value in general, it doesn't return a rounded off value, it returns the actual floating point value as expected. On the other hand, the plus operator also is overloaded to allow us to work with strings for string concatenation, right? And the interesting thing here is it can concatenate not only strings, it can concatenate anything that can be turned into a string. And in Java, everything can be turned to a string. And so it's automatic coercion of primitive types into strings. At the same time, for objects, it's not coercion, it just calls the toString method, which is defined by the base class of all objects, object itself. So once we have that right, the other operators we have are comparison and then equality. So we can use the typical less than, equal to, greater than, equal to, greater than on numeric types. And then equality gives us the capability with the double equals. Now this gets tricky, right? This double equals works with primitives and strings in Java 8 and above. Not equals also works with primitives and strings and enums, right? You can use this on enumerated types as well. And it will return the correct value. But if you use double equals or the not equals on objects, it will only return true if the actual reference is exactly the same thing. Otherwise, it returns false. That's why we also have the dot equals method defined as a part of the object base class that will, which you can override and provide you with the capability to do equals. Furthermore, we have Boolean operators. So these take in these are infix operations that take in Boolean operands on both sides. They're short. The double and the double or are short-circuited, similar to ML's and also or else, right? So if if the first item is false, it does not evaluate the second item. In or, if the first item is true, it does not evaluate the second item. So bear that in mind. We also have the not operator, which is the exclamation point. It's a unary operator, applies to a single thing, and will negate the Boolean value of that. And then finally, we have the ternary operator, which is the sometimes called the Elvis operator. It gives you the capability to you have three operands. The A in this case, so we have A question mark B colon C. A is a Boolean operation, like a Boolean evaluation. If that's true, then the value evaluated is B. If A is false, then the value evaluated is C. This is equivalent to saying if A, then if A, B, else C. It's equivalent directly. If you look at the bytecode that these things are compiled to, the ternary operator literally compiles to the exact same thing as what's written here. So you have to bear that in mind. So, operators with side effects. This is the interesting thing. An operator has a side effect if it changes something in the program environment, like the value of a variable or an array element. In ML and in Java so far, we have seen only pure operators, right? All the operators that we've looked at have no side effects. That includes string concatenation, as I said before. String is immutable. There are no side effects with any of its operations. Now, there's other operators that have side effects, okay? And so, for example, assignment, right? That makes sense because we're literally changing the value of A to make it equal to B. Assignment is an important part of what makes the language imperative, right? We have this capability. We can keep reassigning the value of variables to be something new. We could not do this necessarily in ML, right? That gave us, what we do is we set up a val and it does not change from that whenever we're in that scope. So this gets us to what we call R values versus L values. And this is a little more theoretical, what's going on, right? So why does A equal 1 make sense but not 1 equals A? Well, if we think about this, right, the first one is telling us that we're assigning the value of 1 to A, which 1 is a constant, A is a variable. On the other hand, when we have the 1 equals A, that's trying to assign some variable to a constant. Doesn't seem to make much sense. So what it's going to tell us is that expressions on the right must have a value, right? A1, A plus 1, the evaluation of the function, the method f, unless it's void, of course, which means it has no value. And expressions on the left must have memory location, right? So that would be a variable, right? Has to be able to, and even then, or D at index 2, which is an array, is a memory location, right? On the other hand, the value 1, which is a constant or literal numeric value, has no value, right? That doesn't mean anything. And A plus 1 would be the evaluation of whatever A is plus 1 to that, and so it's a literal or a constant value as well, which means it has no value in memory. So we have to understand that the R value must be some expression, but the L value must be a memory location or a variable. That's all we need to know. That's the difference between L values and R values. In most languages, the context decides whether the language will use the R value, the L value of an expression, right? So there's a few exceptions to this. For example, in the language Bliss, x colon equal dot y, and ML x colon equal not y, right? Both x and y are of type aref, right, in the ML1. So we're not too worried about this, and the R value versus L value experience is not. These languages do not have this notion of what's going on. This is almost a wholly imperative slash object-oriented type of view. So other side effects, right? Compound assignment. So this is a thing that we really have to understand, right? This has implication not only for what we're talking about here, but if you are using this in, for example, concurrent programming situation, same with the increment and decrement below, you have to understand that these are not atomic operations, right? These are not a single operation. They are not compiled to a single operation. If I put in the short Java expression for the A plus equals B, that literally turns into two things. The evaluation of A plus B, and then the assignment of that value to A. Same with the A minus equals B and A star equals B and any other compound expression. Furthermore, if I do the A plus plus, A minus minus, the increment decrement, regardless of which side you do it on, these are not atomic operations. They literally have at least two things going on, and before you use them in certain situations, you need to be aware of what's really going on. I always suggest using the long form, or at least the I refrain from using the plus plus minus minus except for in loop definitions. mainly because it is not the best way of programming. Let's just put it that way. Values to add and side effects, right? So when we use side effecting expressions that have both a value and a side effect, we have to really be aware of what we're telling it to do, what's really going on, right? For example, the value x equals y, right, is the value of y, right? Because we're assigning y to x and then we evaluate x, right? But this comes with the side effect of changing x to the value of y. So if we write a Java expression, for example, a plus x equals b in parentheses plus c, what that is really saying is it's the sum of a plus b plus c, but it had the side effect of assigning b to x in the middle, right? This is not a good thing. Similarly, we can look at the second one, which says a equals d plus b equals d plus c equals d, really is just 3 times d, and then we've also made the assignment of d to a, b, and c, right? Whether or not these are good, I would suggest never doing that, personally, but understanding what it's doing and why it's making this effect occurring. Side effects tend to be, they're necessary for an imperative language to actually work, but they are typically dangerous if you're unaware of what you're doing, and they'll lead to bugs in your code. Now, the a equals b equals c, right, this last one, will evaluate to the value of c, right, because that's the value of a, but it also changes the value of a and b, making them both equal to c. And so we have to understand that that's what's going on in that assignment. So furthermore, and then this gets into the dangerous use of increment and decrement, right? The value that this actually evaluates to wholly depends on whether or not the increment or decrement is pre or post the actual value it's applied to. So if I have a plus plus, right, the value that's returned is literally the initial value of a prior to the actual operation, and then it adds 1 and assigns it to a. Adds 1 to a and assigns it to a. That happens. So this is a 3-step process, right? It first evaluates the value of a, then it adds 1 to the value of a and assigns that new value to a. So there's 3 steps going on here. The second one, plus plus a, first it says it's a plus 1, evaluates that, assigns it to a, then returns the value, evaluates the value, the new value of a. So, and similarly for the decrement operation as well. Understanding this becomes very interesting, and you need to really know what's going on, especially when you're working in like a concurrent programming situation or just any programming situation where you have appears as part of an expression, a longer expression in your code. You must know what it's really doing and why it's doing this. And not all some languages, I can't think of them off the top of my head, but the plus plus a and a plus plus evaluates the same thing. But you need to know the semantics. This type of thing causes lots of bugs with people in JavaScript, C, C#, any language where this exists. It causes people problems, and you should really know what's going on with it and how your language works. So, instance method calls, right? Not all of these have different things going on, right? So basically what an instance method call is basically we have some object reference variable like s in this case, which appears to be a string, right? And this is saying, okay, so we have s, we call an operation that's defined as an instance or an object level operation on that. And length just returns the length of the string, equals to r, test if returns true if s and r are equal, false otherwise. R dot equals s returns the same thing. R dot to uppercase returns a new string that is the uppercase version of the original string, right? But it's brand new. It doesn't modify the one that the object on which it was called. Dot char at returns the character value in position 3. So that would be the 4th character because it's 0 indexed. And then finally, to uppercase dot char at, to uppercase creates a new string, and then we get the third, the item, the character at the third index of that new string. Does that make sense? Okay, good. So class method calls. So these, right? So now we have, so we just looked at instance, right? Instances are objects, classes are the things that define the structure of an object. So there are ways we can actually define, I'm assuming that you know this, we can define methods and fields that are part of the class itself. And that's with the keyword static, right? And so, if we were to make a call on those, we actually use the class name rather than some variable of that class. You can actually use the variable of the class, but it's considered to be confusing to those who read your code, what's going on. So class methods define things that the class itself knows how to do, not objects of the class, right? The class just serves as a labeled namespace holding those methods or those constants or fields, right? So it's a so if we think of packages in which we define our classes to be a namespace that holds the class, and then we can define the class as a namespace itself holding methods that, if they're defined static, are just a part of that module, the class. So they're similar to ordinary function calls in other non-object-oriented languages. They just happen to be with a namespace attached. So, for example, string.valueOf will return a string representation of whatever the expression in the value of is, right? We can have, you can put different things like numbers, objects, and then Boolean values. So any primitive can come in there as well as an object. And it will return a string literal representing them. So, method call syntax, right? There are three major forms to call methods in Java. The three forms are basically we have the normal instance method call, which we saw before, which we can define in BNF similarly as this. It's basically we have the method call, and then this version is basically you have a reference expression. This is something that defines the reference that we're calling it on. The dot indicates the call, and then we have the method name followed by, in parentheses, a parameter list. We have a normal method call, which is where we have what we'll call, I would call this more the normal class method call, which is where we have the class name dot the method name followed by a parameter list in parentheses, and then you can do either kind, right, from within another method of the same class, right? There we already are in the class, so we don't have to refer to the class name specifically. Furthermore, if we're inside of an instance, we can access an instance method as well by just using the method name followed by, in parentheses, the parameter list. Object creation expression, right? Anytime we want to create a new object, we use the new keyword. So the creation expression is defined as simply the new keyword followed by the class name and then a parameter list in parentheses where the parameters are the parameters of a constructor defined inside of the class, right? So a constructor simply is a special method that has the same name as the class on which to which it's going to create, has no return type. So, for example, if I wanted to create a new string, or if I'm defining the string class, I would have the a bunch of different constructors with different parameters, and then it would be like public string, and then the empty parentheses. That would be one. The public string, and in the parentheses another string, etc. And so these are just the different ones, right? If we create a new string with the empty parentheses, this creates an empty string, right? So it's a string of length 0. If we create a new string with the string inside of there, it creates a copy of the initial string. And then if we have characters, right, it's character array. It returns a string that contains the values from the array. Pretty simple understanding that. But we're using the new keyword each time, right? With strings, we don't have to do that. We can actually use the if we're just creating like the empty string, it'd just be a pair of double quotes with nothing inside. The second one, we can actually, we're not going to get into that. That's a different thing. But now we can create objects with the new keyword, and then objects are we have no, like in in C++, we have the notion of the destructor, which is a special method that destroys an object, right, when it's deallocated from memory. In Java, we don't. There is a destructor. It is called the finalize method, but you cannot call it to destroy or deallocate the object from the heap, right? That's not going to work. What happens is the finalize method is actually called by the garbage collector, which comes along when you have no more references to an object. What happens is the garbage collector sees that and is going to deallocate it from memory from the heap, and call the finalize method if necessary to eliminate, if you have certain things like streams open or whatever. But it will take care of all that for you. Almost never do you have to implement the finalize method. General operator info. In Java, everything except for assignments and unary values are left associative. There are 15 different preference levels. You can get into that. You can look up what are the precedence levels of Java operators. It's pretty obvious for the most part. Many coercions, so null to any reference type, any value to string. It's not coercion, that's it. A call, it does work as coercion in primitive types, although it's not technically what's going on. It's auto boxing, then the .toString call. And then reference types to another can sometimes be cast or automatically through the inheritance hierarchy. So that is a coercion, a type coercion that can occur. We'll talk about that in chapter 15. Numeric coercions, right? We all should know this. Things are automatically coerced to a larger type before any operation is applied. For example, characters get converted to ints if we're operating with ints, excluding when we're doing numerical calculations, excluding when it's string concatenation. Ints are automatically coerced to doubles for binary ops, mixing them, right? Everything is automatically coerced up to larger data types at the primitive level. You have to do an explicit cast if you want to go the other direction. So Java, of course, so there's this concept, I just mentioned it, it's called boxing or auto boxing and unboxing coercions. So when we actually do things like we convert to string, right, from an int, what's really happening is for every primitive type, there is a actual object type corresponding to it. And so what happens is to convert an int or a char or a double or boolean, etc., into an actual string. What's going to happen is Java underlying runtime system will automatically convert that to the object representation and then call the toString method on that. So furthermore, if I'm doing, and then this will happen automatically for you. If you need to use, for example, if you're using a collection type like an array list that takes in type integer, right? Because you can't use primitives for that. If you want to add just a regular int like 1 to that list, it will allow you to do that. It'll automatically convert it to an integer for you. And then when you go to do typical primitive operations like mathematical operations, use those operators on those, it will automatically unbox them back down to the primitive type. So that's sort of the Java runtime working for us, and we'll talk more about that in chapter 15. So that's enough for the basic concepts. Well, actually, I think we'll continue. We can continue along. Yeah. So statements. So that's enough of expressions, right? Statements are a compound set of expressions, right? So we have just the expression itself, expression statements. We have compound statements, which are composed of multiple expressions. We have declaration statements, which declare variables. We have the if statement, while statement, and return statement. These are all special with keywords. Statements are executed for side effects, right? If the statement doesn't have the side effect, then it didn't do anything. That's like the base concept of the imperative language as well as object-oriented construct. So expression statements, right? Basic expression statement is it's an expression followed by a semicolon. So any expression followed by a semicolon value is a expression statement, and the value of this statement is the value of the expression. The value of the expression, if any, is discard, right? So we didn't do anything, right? the sole point of an expression statement itself is it does something, but we don't care about the actual value. We're going to just get rid of it. We're not. The only time we actually care about value is if we assign it to something. So, for example, if we execute a call on a void method, well, we don't need to assign that to anything because, well, one, it returns void, so we can't assign it to anything. But two, we're expecting it to do something in in the background that will change some part of the program environment, right? Note that Java does not allow the expression to be something without side effects. For example, like x double equals y, right? There's no side effect to this. It just checks something and returns true. So we have to have something else going on in order for it to be an expression statement. For example, we have like a++, right? That's technically an expression, but it has an assignment going on, as we talked about with the increment decrement stuff. We also have the speed equals 0, right? That's going to be, the value 0 is assigned to speed. This is not really, I would call an expression statement. It's an assignment statement, but I guess we can call it that. And then we have in the red equals cost greater than balance. We check, we say is cost greater than balance. This will return true or false and assign that value to in the red. So those are all the side effects, right? Compound statements. Compound statements are statements that are any list of statements that are inside of curly braces, right? So then a statement list is simply a statement followed by a statement list or nothing, right? You can have an empty, essentially it's called an empty statement where it's just nothing. Excuse me. We can see this as, or we can think about this as a block statement, right? Compound statement is just a block statement. Well, the block is defined by the curly braces, and then anything inside of it is within that scope level. And here we have, for example, curly braces containing a bunch of increment, some assignments, or just nothing, right? And these are all legitimate things that we can do in Java. Declaration statements, this is where we define a variable, right? So if we were to define a variable, we have to first give it a type. Everything in Java, anytime we define methods, we define class, class itself is a type. We define any variable, we must give it the type of that variable first, right? So we have the type followed by the variable name. And then declaration can be compounded with an assignment at the same time. So we can say a type variable name equals some expression, right? So we have a couple different ones here. We have, like, for example, and we also should know that these are then must be they're always block scoped, right? So it could be within the block of a function. It could be within a block of, as we saw before, a compound statement. It can also be within the block containing the body of a type, like a class, enum, interface, etc. We can define all these things, right? So, but they're always we can only define variables in Java up through Java 8 inside of a block itself, right? So when we say boolean done equals false, that's telling us that we define a variable named done of type boolean and initialize it to false. We create point p. It says we've created a point, right? It does not have an initialized value yet. And then when we're in the block scope, right? If we're inside of some method or inside of a block within a method, we create a variable. These have, if you do not give it an initial value, it has no value. It points to, it's not null, it points to nothing. Anyway, so moving forward, right, the if statement, right, we have the if and then followed by parentheses with an expression that we're going to evaluate. If that expression is true, we execute the statement. On the other hand, we can have the if expression in parentheses, and then if that, again, if it evaluates true, we execute statement. Else, we have, if that's, so in other words, if it's false, we then execute the next statement. It's pretty simple, right? We have these defined. Our statement can be a compound statement, giving us the capability to have more like a statement list as a part of our if and our else as well. So we can do more than one, similar to a let block in ML. And then we resolve the dangling else problem in the usual way, which is the else is attached to the closest if. So we just have to understand that. The while statement, right? We all should know this. It's while followed by an expression in parentheses. If that expression is true, then the statement or following is executed. Otherwise, we do nothing. So it evaluates, as it said before, iteration. That's what this is the hallmark of imperative languages, of course. We also have the do and for loops, right? So the do says do this next statement or list of statements. And then there's followed by the while keyword and then an expression. And so then we evaluate that while expression. If it's true, we execute the body of the loop again. Otherwise, we do nothing. So a do is a while that executes at least once. For is a little bit different. There's two different for loops in Java, and we'll talk about them, I'm sure. But these are just examples of while and what they mean. I expect you guys to go to know most of this already. It's pretty simplistic what's going on. Finally, we have the return statement. Not to be demeaning, if you do not understand, I'm not saying that it's simplistic as in you should just know it. I'm expecting you to already have learned this in the past. So I'm just trying to get through this as fast as we possibly can. The return statement note is the return keyword followed by some expression. The value of that expression is going to be returned by a function. Note that expression's type must match the return type of the actual method, right? If the return type is void, you cannot have an expression. So it has to be the second return, which is just followed by a semicolon. If you do have a return type, that expression must match the type. So note that. You can have multiple returns in a given method. It does not have to have only one. And furthermore, the last statement of a method is not automatically returned as it is in Ruby, ML, etc. All right, so that was a really long section. The next section will be on class definitions. So I'm going to stop it here, and then you can continue on part 3, theoretically.